Okay, so in this video, I want to discuss how to use an inductive PNP proximity sensor with a microbit and Keytronic all-in-one breakout board. Now to start off, we might as well talk about what is an inductive PNP proximity sensor. Well, inductive, basically what the inductive part is that this sensor can basically see or detect anything that can conduct electricity. So for instance, copper, gold, silver, cast iron, whatever else it might be. As well as that, it is a PNP, so that means it's positive, negative, positive. And all that really means is that when something is in front of it that it can detect, it sends back a positive high back to whatever it goes back to. For instance, now we have this microcontroller. And then our proximity, basically it detects it if it's in front of it, and it is a sensor. So how are we going to wire this up? Well, to wire this up, we're actually going to need two additional batteries. Now, I have two 9-volt batteries here. The reason I have two 9-volt batteries is because one of the 9-volt batteries is going to be to power the all-in-one Keytronic breakout board, which takes up to 10.8 volts, and it will supply 3 volts to the microgrid board itself. So that's what one is for. But because this sensor actually takes between 6 and I think 36 volts, what we'll need to do for it to work reliably is we'll need to give it as, I suppose, the highest safe voltage that we can give it. And to do that, I'm going to give it its own 9 volts. Now, you could wire it in that it goes back to the 9 volts going to the board itself, but I find that it works most reliably when you have an additional battery like this 9-volt one here. So what's it going to look like when we put it together? So if I bring the wiring diagram here in front of us and we have a bit of a talk through it. So we have our 3 to 9 volts going to the actual, I suppose, all-in-one breakout board itself, which is then supplying 3 volts to the microbit, which is slotted into this slot here. Then all we're going to need is two 10K resistors, as you can see here. You're going to only need to use 2 of the additional breakout pins here, and we're just going to use pin 0, and we're going to use the ground pin just to ground everything. It's going to be connected up to our two 10Ks. One of them here is going to lead off to the black wire of the PNP sensor. As you can see here, we have 3 wires coming off the PNP sensor: black, blue, and brown. Then we are going to have another one that's going to go to our 10K, come over here, come down to our ground, and also go back up to our blue. Now, what's important here is we're also going to have an additional wire coming off of that, which is going to go to the negative side of our additional battery. And then through that additional battery, we're going to have a plus, which is going to go to the brown lead of our PNP sensor. So now that we have all the wires connected up here, it's important to note that we're going to use between 6 and 9 volts. That's because the working operation of this PNP sensor, which actually should be stated on it here somewhere if I can find it for us. Yep, so it should be here. Let's have a closer look if it zooms in on us. So you can see it's 6 to 36 volts DC. So that means we need to have something between 6 and 36. So what we're going to use is a 9-volt battery. Now to put it all together, I'm just going to use this small bit of a 3D printed test rig or demo rig. I just have it here so that it can hold our 9-volt battery here, also hold our Keytronic all-in-one breakout board, and then instead of soldering all the different components, I'm just going to use this bit of a breakout board just to join the different wires. And then I've up here just this little slot to fit my PNP sensor. Okay, so this is it put together. Now let's compare it against our wiring diagram. So if we put our wiring diagram here, we'll put it underneath. We have our PNP sensor, we have our black, we have our blue, and we have our brown. So if I go to my PNP, go all the way to the end of my wires, and I can see here at the very end, I have my black, I have my blue, which should be here, as you can see, and the brown. So if we follow black first of all, black should come all the way back and back to one of my 10Ks, which then will be connected back to pin O. So if we go black, bring it all the way back, follow it all the way back along. You can see here that it goes back to our breadboard, which then is joined up with this 10K resistor, and then goes all the way over here to this wire and back to pin O of our breakout board. Then if we look at our blue, we can see that it travels back out here, then it connects back up to the ground of our additional 9-volt battery, and then comes all the way back down to the ground of the breakout board itself, as well as that it's connected back to this 10K and back into the circuit we were previously talking about, or the previous wire we were talking about. So let's follow that back. So we go to our blue here, we can see that it breaks off into two. It goes back here to the ground of our additional battery, which would be connected up to this here. And then we can see that it also comes back all the way back to our breadboard, where it is connected back to another wire that connects up to this black wire that goes back to ground. And as we can see, it's also connected to 10K, which jumps across again to the previous wire we were discussing, which goes back to that additional pin. Now, the only thing that we're missing is this last brown, which only connects directly up to our additional battery, our 9-volt battery. So if I follow that, so if I go to my brown here, you can see it just goes straight off to that additional battery. And you can see also we have our black and our red wire going back to the battery that powers the microprocessor itself, the microbit, and the Keytronic all-in-one breakout board. So what we'll do now is we'll jump over, we'll have a look at the code, and after that we'll test it out. Okay, so now that we've moved over to our microbit code editor, what we can do is start off by deleting our on start block. We will not be needing that, and we'll just work with our forever block here. Now, what we want to do for this proximity sensor, this PNP inductive proximity sensor, we're going to want it to indicate to us when it sees that conductive object in front of it. So what I would like it to do is to see when that proximity sensor is sending a high signal back towards the microbit itself. And when it gets that high signal, I want it to display, let's say, an M on the 5x5 matrix, as well as make a sound to make it very, very clear that there is an object in front of the proximity sensor, a conductive object. And then what we want to do is when there's nothing in front of it, for it not to make a sound and also have nothing displayed on the P or the 5x5 matrix itself. So what we're going to start off with is an if block. So we're going to go to our logic. We're going to go for our if block here. We'll start off with something basic. And then we also want to get one of these comparison blocks, like so. We're just going to swap out our true here, there. Now, for our comparison block itself, what we want it to do is to read our analog read pin O, because remember, we connected it back to pin or pin 0. So if we go to variables, we go to, actually, then we won't go to variables, we'll go to pins, we'll go to analog, because it's an analog signal that will be coming back, and then we'll leave it at pin 0, as you can see there, because that's the one's connecting back to. And we say when it is over, let's say 900, that's when we know that it has a high signal. So if it's below 900, it's going to be not basically sending back a high signal, and when it's above, it's going to be above 900. Then we're going to go back up here to our basics. We're going to say that if this is true, it's going to show an M. So let's create an M with our 5x5 matrix, like so. And I also wanted to play that sound. So we'll go for music. We'll go all the way down. We'll say play sound. Slot that in. We'll leave it at the frequency, end frequency, duration. That should be fine. Let's see if we can also make what happens if that is not true. So we're just going to click this plus, and we have else. So basically, if this is true, so analog read pin 0 is greater than 900, so that means there's a high signal coming back from the PNP sensor, which means there's a conductive object in front of it. Show them and it will also make that sound. But if this is not true, I don't want it to play a sound, so I won't put any sound below here and else, but I will say it's going to clear the screen, just in case that previously it saw something and it still has the M up on the screen. So it will automatically remove the screen from the display itself. So let's go to clear screen and we'll drop that there. Now what we're going to do is we'll upload this to the microbit itself and see how it works. Okay, so now that we have our code done, we can upload it to our microbit itself. Then we can connect up our additional power supply like so. And then we can connect this power supply back up to this battery pack here. So we're getting our 9 volts directly to our breakout board, which is supplying 3 volts to our microbit. Then we have our additional battery, which is basically powering the inductive PNP proximity sensor. So now it should be working as long as your switch here is on. You can also see that there is like a little bulb at the back here, which should indicate is if there's something conductive in front of it. And it also should show the M and make the noise. So if I get something, let's say like these pliers. Now I know that this is a conductive material, so if I put up against it, you can see here it throws up the M, and it also makes that beeping noise. And as well as that, you can also see that very likely it shows this light at the back. If I take it away, that light goes, the M goes, and the flashing goes. Like so. Now it works for all conductive materials. For instance, if I put this plastic in front of it, it will not work. But if I use the other end, it should work. Like so. Not like so. If I get something else which is not conductive, I get something else that is conductive. My little screwdriver here.